Simulink Data Dictionary. In short form, it is called as SLDD. Okay, and if you have to make change to any particular feature or any particular variable, I've selected a variable here called as voltage, which is the maximum voltage. You can click on this. Once you click on this, this space, right? You click on any particular variable, in this space, this appears. It shows that you have selected a signal, which is basically a variable. You can choose its data type, and all the others are there. Here you can go and choose. If you want to change the data type, means what data type that you are going to, its dimension, minimum, maximum value, and all these information you can enter over here. If it has any initial value, you can enter it here. If it's a calibration data, you can directly enter the calibration value here itself, right? And also you can choose your storage class. That is for your input variable, output variable, and local variable. For each type of variable, you have different storage classes, which you can choose and you can work on, right? So about how you apply different storage classes for different things, that and all, probably once you take up the course, you can learn more about it. And another important thing one needs to take care of being a model-based developer, that is, we saw about the requirement analysis, requirement tagging and traceability. The third thing is about the Simulink Data Dictionary. Fourth thing is about the port properties check. When you are choosing, see, your ports are like your doors, like how for a house or for a building, the doors are the entry point. Similarly, for a model, your ports are the entry point. Your input is the entry point and your output is the exit point. Okay, so you need to define your properties of your ports such that without any issue, without any computational issue, your signal comes in and it goes out basically, right? So here, this is like, say for example, you have an input, means this has to be some of the common properties that you need to take care of. For inputs, your data type must be inherit auto, put dimension must be -1, sample time must be -1 as well. Okay. Likewise, displaying of your signal names. Okay, you have a signal. See, you have this AND block. From the AND block, you have connected it to an output. All your signals, so any line which connects a block to a port or one port to another block, that is block, port, block, whatever order that a connection is established, that is called as a signal. And an appropriate and a logical name has to be given for that signal. Okay. Like a label, or it can also be called as a label basically, right? And a label must be displayed at the origin for the following blocks basically, like input, from, subsystem, chart, whatever block that you are using, and a label must be displayed for it. And once you create a signal, you have drawn a label. Say for example, you between this AND block and this output, you connect and you give this name as valid start. Once this valid start is created, you can right click on it and choose its properties. Also, if you are not giving the name over there, you can enter the name over here. Usually you double click on the line and you can directly type the name. Otherwise, you have to right click, go to properties, and then you have to give. Also in this, you can fix some of the properties, like properties with respect to the propagated signal, signal resolving, and all that can be taken care of over here. Okay. And about signal resolving, the significance of signal resolving, why we need to resolve the signal, and all that. It's like the time constraint is too small to discuss these things. The same thing goes for propagated signal. Signal can be from an innermost layer to the top layer. It can be used. When you are using a signal only at the point of origination, you resolve that signal and you manually enter the name of the signal. At the other upper layers, we usually go on to comment it and take it to the topmost layer. So this is called as propagating the signals. So this is what we do with signal propagation. And the last stage of it is like, so this pretty much with that, we will take care of all the model development related issues. You can click on the play button at the model. Once you click on the play button at the model level and see whether your model is simulating, which means that it takes the signals, its values from the Simulink data dictionary. Through the ports, it goes to the different blocks. Logics get executed. Once all the logics are perfectly executed, it must run the simulation and it must stop. Once this is done, it means that your model is working perfectly fine. If it is not working, there will be certain errors or there will be certain warnings which the developer needs to correct, and then after that he needs to try model simulation. After the model simulation, the next stage is about the model advisor. See, in model advisor check, if you can go, since it is not like, since software development here, it has to go through different levels of testing, and also like how, for example, if you are trying to buy any appliance or a product, for each product some sort of ISO standards are there that needs to be taken care of. Likewise, for the embedded software that is being developed, certain ISO standards are there, certain guidelines are there, according to which only your software needs to be generated or your model needs to be developed. Okay, so these guidelines and standards, they are coming from something like something called as MAB is there, MathWorks Automotive Advisory Board, who defines the standards as on how my software must come. Also, ISO 26262 standards are there. These are some of the functional safety standards that are followed during your model development stage. So what you do is, and you simulate the model, you open the model advisor check as we show here. Once you open the model advisor check and you run it, it runs. And after you run it, it will throw some set of warnings and error messages. Based on this warnings and error messages, you may have to make changes to your model. The reason why these warnings or error messages usually come is your model, you have developed a model, your model might have the correct logic, but it is not the standard that it is expected. So in order to fix the standard, you don't go to a shop and you don't buy a product that is of not good quality, right? Similar thing is being followed here as well. Your model is not of the perfect and expected quality. So you need to make these sort of changes to your model. Once you make these changes, that is, it is called as MAAB checks and also ISO 26262. These are some of the functional safety standards that is being adopted for embedded software development. So once you take care of all these points in model advisor checks, the next stage is code generation. The toughest part is to develop the model, ensure that your normal Simulink model goes to MBD standards. From there, it goes to the functional safety and industrial safety standards. Once it is all taken care of and your simulation is all perfectly fine, you just click. There is a button like this that can be there in MATLAB. Okay, there is this button like this, which will be found in your MATLAB window. If you can see here, this is my Simulink window. In my Simulink window, you can see something like this. You can directly go and you can click on this button. Once you click on this button, the code gets generated. And once this code is generated, the next stage of it is the verification and validation. So, okay, again, as I said, once your simulation is done and once your model advisor report is done, you can do model in loop testing. Once your model in loop testing is done, the next stage behind that is the software in loop testing. So the next stage of it is like the software in loop testing. So briefly, the model in loop and the software in loop or testing as a whole, what we do is like we call that as the verification and validation. Okay. First we will verify it whether whatever we have developed is correct, whether we have followed all the process behind it. Next is the validation. Okay, whatever that we have developed, right, whether it is exactly what my customer wants. You can follow all the process, you can develop it and you can give it. What if your logic is wrong? What if you have chosen the wrong data type of variable and all? So in order to find them and in order to your model advisor reports or others will not tell whether this particular variable you have chosen the wrong data type. It is not following the expected logic. It does not tell all that. Only in the testing stage you would be able to tell this. So this basically coming under your verification and validation. So what are some of why verification and validation is important is, like, sometimes you have a software that is developed. Say for example, at a certain level your airbags need to open up in your system. For example, in case of a car crash, say for example, your sensor which detects the crash, it needs to send a signal to the airbag to open. If in case that sensor is malfunction, if in case the software which detects that level of crash, intensity of crash is not working perfectly fine, your airbags may not open up. That can, see, this is a very, very small logic. This is something that can only be controlled by a software. But if that is not sending me the proper signals, it can result in loss of life or illness. So these kind of things comes under a safety critical. And sometimes, okay, certain things, you try to hit the brakes, you have your anti-lock braking system, your entire anti-lock braking system logic is not working. All of a sudden you try to hit the brakes, your brakes is not hitting at the expected level, and you end up crashing your vehicle into something. That can cause an external damage as well. Okay, again, for anti-lock braking system feature to work, apart from your sensors and actuators, you also need a proper software, running software that is there. So all of these things come into the picture. And the reason, see, you just can't develop a code, try to directly flash it into an ECU, and you can't run it, right? To ensure that whatever software that you have developed is first of all safe and it is of expected standards, that is why we go for verification and validation. So what are the different stages of verification and validation that we do is, like, we take care of both like functional validation and structural validation. Okay, in functional validation, what we essentially take care of, whether a certain logic is expected to be performed. Okay, you have to do some basic multiplication or addition or whatever that is, whatever logic that you have taken care of, whether all that is taken care, that comes under the functional validation. And structural, and that again involves different verticals, something like model in loop, software in loop, and hardware in loop. Okay, so what usually does is, like your developer, a tester would be there. Your requirements, based on the requirements, you develop the model. Based on the requirements, a tester will write the test cases. Okay, so what usually happens is, like, functional requirements, a model goes in, and also from the requirements, test cases are developed. So with the model and the test cases, he develops some test scripts. Final set of test cases are all done. A test automation framework would be created, and from there the test results we would be getting it. So usually we in one of the earlier slides we saw about how third-party tools are helping us with respect to the testing. So all these test automation framework and all that, it differs from one tool to another tool. So you anyone who's trying to know more about it, you need not focus much on that. All that you need to know about is, like, you need to understand the requirements, develop your models based on that, how you do testing, at what stages, if you find any issues or bottlenecks, how are you going to solve it? All these things only one needs to take care of. Okay, again, as I said, we saw already in the earlier slides, we saw about what a model in loop testing, software in loop testing, and hardware in loop testing is basically. So the last stage of it, I think we can rush up with these. So once anyone who is taking up what model in loop or software in loop testing, you need to be aware of what unit testing, integration testing, system testing, and acceptance testing is. So this mill, sill, and hill are different testing techniques. Okay, and different ways of testing is basically this unit testing, integration testing, system testing, and acceptance testing is. And there are certain metrics that are being followed at the testing level. So these metrics are how much, whether whatever test cases that my developer is writing, whether all that based on that only my model is developed, and all that he has to see. So for that, there are certain metrics which evaluates and gives that. They are called as coverages. You get a test report at the end of testing, be it model in loop or software in loop. You get a test report, and in that test report, you will have certain things like decision coverage, condition coverage, and MCDC. You just need to ensure that everything is 100%. Basically, if it is not 100%, you need to identify and say why it is not 100%, and you need to appropriately fix it. Okay. So this is how a test report would look like. And so in this test report, these are some of the snapshots that I have taken. Okay, anything which is highlighted in red color, that particular condition is not tested, it means. So you have to go back to test it. Okay, so I can rush through all of this. So each of these things, when you're taking up the course, when you're trying to learn about it, you can go into these things and you can work on it, and or you can learn more about it, basically, right? So this is with respect to the test analysis. So the last stage, so we have pretty much covered on what model-based design and corresponding testing. So the last part of the presentation or the webinar today is about the ADAS. Okay, anywhere you go in today's market, the OEMs are striving and are looking for driverless cars. Okay, back in the olden days with the old Maruti cars or the Ambassador cars, if you can see, it was completely laborious. You didn't have power steerings. You need to roll up your windows every now and then. You had really heavy doors which you have to manually lock them and all. Seat belts were not there. Safety related stuff was not there. But today, the job of driving is becoming a lot more easier. Okay, and the job of drivers is also becoming a lot more easier, right? So ADAS is one of the features that is being developed across all the cars. All the OEMs are working on ADAS related features. Even for developing or emerging markets like India, we have ADAS features which are being implemented in Indian cars at very, very small level. You know, Hyundai Creta, that is a car which is being sold in good numbers in India, that has ADAS features. Okay, that has adaptive cruise control feature. Basically, almost all the cars that is coming in Indian market today has autonomous energy braking, right? Which is basically like anti-lock braking system. Right, so these kind of features are being introduced. So ADAS features are basically introduced to improve the driver safety, passenger safety, and also to ease the whole driving process for your driver. Okay, so this is the ADAS feature. And ADAS, so this is about, so this illustration, whatever that I'm showing here, is the different levels of autonomous driving that is being looked at the market level. So level 0 is something that has no support or assistance for the driver. He just has to sit, he has to drive, he has to take care of all the things, right? He has to see the road, he has to ensure that no one is coming in between, he has to hit the brakes correctly, he has to see around, even if there is a blind spot in the car, he has to ensure that no other vehicle is just coming and hitting him. All these he needs to take care. As different levels improve, you can just see in this picture, his comfort level also improve. You go for a feature like adaptive cruise control, right? You can set at what speed your car can go, and you can remove your leg off your accelerator. Okay, your vehicle goes at that particular speed, it brakes appropriately. If you feel manual braking needs to come in, you can directly go and manually hit the brakes as well. So this is as far as adaptive cruise control. The next one can be traffic control, depending on the traffic sign. Okay, sometimes this is something that is very, very common among Indians, driving on no way. Your traffic board would say that you have to only drive at 60 kilometers per hour. We drive at 80 or 90 kilometers per hour. We try to go fast. There would be something like no parking, one way, no way. We don't mind it. We simply go in. Okay, drivers can make that mistakes, but software algorithms are today developed in such a way that if you drive along a no way or a one way, or there is a road where you only have to drive at 60, but when you're trying to drive at 80, a sensor, a camera would be placed at the windshield, at the glass in front of the vehicle. It will capture whatever sign that is present in the road. It will give an information back to the driver. It will vibrate your steering wheel and say, come on, hey, you should not go in this way. You should drive only at 60. All of this is called as traffic sign recognition. This is also an ADAS. So slowly but surely, when you're moving from one level to another, the enhancement of the features kick in. The enhancement of features come into the picture. So what the companies are looking at level 4 or level 5 of ADAS. See, as far as Indian market is concerned, we have probably until level 1 or level 2. You go to something like European, level 3 of ADAS is being implemented. Level 4 and level 5, still the research is going on. What they are looking at is like, you just give instruction. A passenger has to get in. He needs to just give the instruction. A driver physically won't be present, but your car will become a super machine, which is going to take you along to your required destination. With complete safety levels, it needs to drop you there at your destination, like how your driver does. So this is the level of autonomous driving what the companies are basically looking at. So as far as ADAS is concerned, who are the major stakeholders here? Okay, I can openly say that Tesla is working. Tesla is doing some amazing jobs with respect to this. Companies like OEMs, basically like Ford, Renault, Nissan, BMW, Toyota, all these guys are working. Suppliers like Bosch, Continental, Infinity, Delphi, all these guys. Harman is also like working a lot on majority of these applications. Okay. So with this, we have just come to the end of about what ADAS is and what are some of the basic features like adaptive cruise control, autonomous driving, anti-lock braking system, and all this comes under different features of ADAS, which is being developed in India. See, BMW is there in India, Harman, Infinity, Nissan, Renault, all these guys, Bosch, Continental, all these guys have their facilities in India. And each of these guys, you go to any of these websites in LinkedIn or anything, you see the need for qualified engineers who work on MBD is there, or you can see people, you can see hundreds of people who are actually working on ADAS. So if you can go to the core thing that one needs to focus on with respect to this course is to be a good MBD engineer. So anyone who attends this webinar, who wishes to take up this course and work on, what you have to strive to look at is like how good an MBD engineer I am going to become. Okay, you need to develop your MATLAB simulation skills at the highest level. You need to understand the requirements. From your requirement, you need to develop your model. Then you need to stick how quickly you are able to stick to the MBD standards. Okay, you have to follow certain standards. Okay, how you are going to work on it. See, certain works will be laborious and manual kind of a job. Okay, you can look at something like automating your work. You can develop some scripts which will automate your job. Manually, you go and fix some properties. Instead of that, you can develop a script in MATLAB which will run quickly to save your stuff for you. So all of this and all comes as a part of, so these are something that is demanded and expected from a MBD engineer. You need to have good amount of knowledge and idea about what model in loop simulation is. You need to convert your model into an autocodable model. You also need to have good awareness of what embedded coder is, what AutoSAR coder is, and all of this. You also need to have a good amount of awareness of how to do software in loop simulation and testing. So all these are the demands for an MBD engineer. See, this MBD engineer, so this can be applicable to different fields. An MBD engineer can go and work on powertrain control. He can go and work on body control. He can go and work on battery management system. He can also go and work on ADAS features. And one of the most important And the key feature that is there in today's market is basically ADAS, and that and the gist of that is what we saw right now.